And welcome back, everybody. We are now in Chapter 5, Section 5 of College Algebra from Marion Technical College. We're taking a look at polynomial and rational inequalities today. So we want to solve polynomial inequalities, and we'll also solve rational inequalities. So what is an inequality? Well, an equality is an equal sign. Inequality means that it means that we're not equal to. So not equal to, so we're less than or equal to, we're greater than or equal to. So those are the things that we're going to be taking a look at. We're going to be taking a look at these sorts of items today. So let's take a look at example number 1 here. Let's solve a polynomial inequality by using a graph. So if we have x plus 3 multiplied by x minus 1 quantity squared greater than 0, and we want to solve that. So we want to know for what x values is this particular item bigger than 0. So effectively, when is it positive? So graphically, when is it above the x-axis? So what we could do then is we could solve this. One way to solve this is graphically. We take a look at the factored form here, and we go ahead and graph. So we've graphed polynomial functions before. So as we take a look at this, we would say, when does this go to 0? So when do we have the x-intercepts? The x-intercepts would be when x plus 3 equals 0. So when x plus 3 equals 0, that's when x is negative 3. Also when x minus 1 equals 0, or when x is 1. So we have these. We see the intercepts down here at 1, 0, and at negative 3, 0. So that makes sense. This x plus 3 has a multiplicity of 1, so we're going to end up going through at negative 3, which we do. And this has a multiplicity of 2, so that means we're going to turn at x equals 1, which indeed it does. If we take a look at this further, we could say, all right, we've got the x and then an x squared. So x multiplied by x squared is going to look like x cubed. So as far as our end behavior, we got one side going down and one side going up. So if we know that we have that, we could go ahead. If we were doing this all by hand, we would plot the negative 3, 0. We would plot the 1, 0. And then since I know I've got to go through over here and I've got to turn here, I must be coming up and in turn somehow come back down, hit that point, and then back up. So that would be a rough sketch. Now obviously we have the full sketch here, but that would just be a quick review of what we're doing overall. Now as we take a look at this, the other thing that we want to figure out then is where is this above 0? So 0 is the x-axis. So where are we above 0? Well, we are above 0 in this range, and we are above 0 in this range, but not at 1, 0, because this is strictly less than, not less than or equal to. So we don't want we don't want anything on the axis, so it's got to be an open dot here. This must be an open dot here. So the interval when this occurs is between negative 3, exclusive of the endpoint, all the way up to 1. And then we're going to union that with from 1 out to infinity. Okay? So that is our solution set for this particular question. Nothing else to do on this. We're visually taking a look at it. When are we above the x-axis? And that's the thing that we'll do when we solve our inequalities. We'll always end up comparing to 0, because then we're either, okay, since this is the axis, we're either above the axis if we're greater than, or we're below the axis if we're less than. And then it becomes a visual item if we've graphed it. Now there's another way we can take a look at these, which is purely algebraically. Okay, so on this next example, we're going to take a look at it algebraically. Zoom this in just a smidgen. So solve the inequality x to the fourth is bigger than x algebraically and graph the solution set. So overall, if I would just take a look at x to the fourth, I know overall that's got to be something like this. And the graph of x is this. So what we're looking for, when is x to the fourth bigger than x? So I'm looking for what is this region out here and this region here. Now, from a rough sketch, I really need to do a little bit more detail because I don't know where those values are. But I can go ahead and solve this algebraically as well. So let's take a look. So if we do that, we got x to the fourth is bigger than x. What we want to do is we want to compare this to 0. So x to the fourth minus x equals 0. So I'm going to need to move this x to the opposite side. Let's factor this. So I've got x, that's going to be x cubed minus 1 is less than 0. And so that means that this would be x. See, x cubed minus 1 is a difference of cubes. So that's going to be the cube root of each of those. Keep the same sign. Then we're going to do, let's see, to get x into x cubed, we got to multiply by x squared. But then we got to cancel out some terms, so that we're going to need another x term in there. And then let's see, we're going to multiply by the square of this term. So it's the square of the first term, square of the second term. Then multiply those two together. And it's always the opposite sign of what we started with. So all of that ends up being less than, so our original was greater than 0. Minor mistake here. Let's change that. So it should have been greater than 0, greater than 0, greater than 0. I hate when I make those minor mistakes that way. But one thing that does show you, hopefully, as you watch these videos, is that as we do mathematics, occasionally we do make some odd mistakes. Now, I could go back through and try to edit this out and refine the video, and that may, you see that there's never a mistake anywhere. But it's not really realistic, in my opinion. When we do mathematics, we are always going to make some minor mistakes. Just go back through, we see them, we fix them, we correct them, and then we move on from there. Okay? So as we take a look at this particular item, what we're going to focus on is this piece. Okay? So when we say algebraically, what we want to do is what is called a sign graph. Okay? So what we're concerned about is where is the sign of the function positive, where is it negative. So what our critical pieces are going to be then is what makes the items in this box here now, what makes this go to 0. And then if we're positive, we're above 0. If we're negative, we're below 0. We're going to be interested in specifically, when are we above 0, because that's greater than. So when does this whole thing go to 0? Well, when x is 0, when x minus 1 is 0, and when x squared plus x plus 1 equals 0. We're using the zero product property. So if anything multiplied together equals 0, one of those things had to be 0. So we switched from inequality to equality at the moment, just figure out what our critical pieces are. So we got 1x equals 0. We're going to have 1x equals 1. And on this one, if I try to factor this, what are the factors of 1 that add to 1? Well, there isn't anything, so that one doesn't factor. So there are no pieces on this. And when we do the difference of cubes, this thing particularly, or this factor, with very few exceptions for what we will do, ends up not being able to factor again. So that'll go to not being no factors. There's nothing interesting as far as what we want. So we're going to do 0 and 1 over here as far as our interesting pieces. So what we know then, basically from our graph, is at 0, we've got this point here, okay? And at 1, we've got that point. So what I should see over here on the left of 0, I should see that this is positive. Over here between 0 and 1, should see that that's negative, because that means x to the 4th is below x. And then over beyond 1 should be positive again, okay? Let's take a look and see what this looks like. So what I could do is I want to choose a value on the left side of 0. So one thing I want to take a look at then, let me grab my highlighter. Let's take a look at this. Okay, so when I take a look at that, I'm not concerned at all about the actual values. I'm concerned about positives and negatives. That's why this is called a sign graph. So let me choose, let's see, let's call this f of x. Let's maybe choose f of negative 10. It's just some value on the left side of 0. So negative 10 here would be negative, and at negative cubed would be negative, minus 1 more is still going to be negative. So we're going to end up with a negative times a negative, so overall this region's positive. Between 0 and 1, let's do maybe a half. So if I choose a half in here, let's choose this piece down in here. I got a half is going to be positive. I've got a half minus 1 is going to be negative a half, so that's negative. And over here, I've got a half squared plus a half plus 1. So everything's positive all added together, so it's got to be positive. So we got positive times a positive overall is negative. Again, I'm really not concerned about the actual value. All I'm concerned about is it positive or is it negative. Out here beyond 1, let's just choose something out there that's easy to work with. Maybe we'll choose 5. So I'm going to go back up into here. So I got, or I could do this. I'll do both. If I choose 5 here, that's positive. And then 5 cubed is going to be 125, minus 1 is positive 124. So I didn't need to know specifically it was 124, I just need to know that it's positive, and positive times positive is positive. Had I chosen this other group, then at 5 it would have been a positive. 5 minus 1 is 4, which is positive, and all of this is always going to end up being positive if we're using positive numbers. So that would have been 3 positives, and overall still would have been positive. What we were interested in was when was this bigger than 0? So it's bigger than 0 when we're positive, so it's in these two regions. Notice it's strictly greater than, so I don't include 0. So my solution set here is from negative infinity, it's a lousy infinity sign. Let's clean this up. There we go. Negative infinity up to 0, combined with 1 out to infinity. Okay. So algebraically, that's what we do as far as our sign graph. Graphically, I could have graphed both of them and say, okay, x to the fourth was this piece, x was that one. When is the u-shaped bigger than the line? And it was bigger than the line between 0 and 1. That would have been where they crossed each other. Okay, and so we've got it. We've solved an inequality. So if I go back, let's take a look at Desmos here. X to the fourth minus x, if I graph that, this would be the graph if I put them both together. And so at 0 and at 1, we see here we're bigger than 0. Over here we're bigger than 0. So we're going from negative infinity up to 0, and then from 1 out to infinity, which is what we said it was. The other thing I could have done over here is I could have said x to the fourth, and then x. This was a graph that we had that I did previously on the tablet. And so we had, when is the red function above the blue function? So it's between 0, it's between negative infinity and 0, and it's below between 0 and 1, and it's above on the right side of 1, which is the same function I was trying to get at over here also. Okay, so again, I find these kind of fascinating. I think these are kind of the fun items. I think, was it section 5, we're in section 5.5, I think section 5.4 and 5.5 are the fascinating items in algebra where we get to do some graphing, get to see what things look like, do some solving, and like I said, just in my opinion, some fun stuff here. Let's go ahead and solve a rational inequality using a graph. So we want to solve x minus 1 over x squared minus 4 greater than or equal to 0, and we're going to solve that. Now on this one, we're going to use a graph. Okay, and then we'll do another one where we do it algebraically, kind of like the last set we did previously here in the last, well, we got 20 or 13 minutes. I was going to say 20 minutes. We're only 13 minutes into the video today. So let's see, on this one, we want to graph this. So when we graph this, this is something we did in a previous video. Basically, we're interested in what are the key pieces from our numerator. So when does our numerator go to 0? Well, that's going to go to 0 at 1. Really, that's the, if we're doing the full graph, that is our x-intercept. When does our denominator go to 0? So x squared minus 4 equals 0. So this would be, this factors into x minus 2, x plus 2. So x minus 2 is 0, or x plus 2 is 0. So as we solve that, x is 2 or negative 2. And so if we were trying to factor this overall, in lowest terms, this would be lowest terms. So the key pieces are when does the numerator go to 0, when does the denominator go to 0. So down here we end up with our vertical asymptotes. We got a vertical asymptote at x equals 2 and x equals negative 2. We've got an intercept at x equals 1. Let's see here. So at negative 2 and positive 2 and x equals 1, we got a key piece. So what we would like to know then as we graph this, what else does a graph look like? And so let's see, on each of these vertical asymptotes, these each occur only one time. So these are odd multiplicities. So that means we're going to be positive on one side, negative on the other of each of these asymptotes. Okay, x minus 1 is also an odd multiplicity, so we're going to go through that one. If I figure out the y-intercepts, okay, that means I want r of 0. So that's going to be -1 over -4. So that's a fourth. So that's going to be up here. So just from this information, I think we have enough that we can figure out the rest of the graph. Let's do one more piece though. Let's do the end behavior. So as x approaches positive or negative infinity, r of x will act like, let's see, x over x squared, which is 1 over x, which as we go to infinity is going to end up going to 0. So I'm going to have a horizontal asymptote at y equals 0. Okay. So on the ends of the graph, we're going to then approach 0. So overall then, now let's see, so I only cross the x-axis here, and I'm above it over here on the left. That means I must have been coming down over this way. And since this is up on the positive side, as far as infinity, over on this side must have been negative, be coming up this direction. And on this, the same thing, since this is going down, this piece must have been on the upside and then coming down. So that is a quick graph of the rational function x minus 1 over x squared minus 4. So when we did that a few videos ago, we had like 6 different steps, and we took our time identifying all those parts and pieces. The more we do of these, the quicker we come at it, and the more we recognize the key pieces of information then are what makes our numerator go to 0, what makes our denominator go to 0, and what are their multiplicities. Then we take a look at the intercepts, okay, so at r of 0, so a lot of zeros in here, and then what is the end behavior? So as x goes out to positive and negative infinity, what does this really look like? Now, that's the graph. What we're really interested in is solve this, and when is this greater than or equal to 0? Okay, so when is it above the x-axis? So it's above the x-axis over here, and it's above the x-axis out in this regard. Okay, so where are those? Okay, so let's see, our solution is going to be between -1 and 1. So that was -2, my mistake. -2 and 1. So at -2, we had the asymptote, the vertical asymptote, so we don't count that as part of our solution. However, here at 1, that was equal to 0. So at x equals 1, y value is 0, and we wanted or equal to. This is x minus 1 over x squared minus 4 is greater than or equal to 0. So we want to count the 1 as part of our solution. And then we could say either comma and then write the next piece, or we could say union with, and then again, this is an asymptote, so that's going to be 2 out to infinity. So that would end up being our solution in this particular case. And that finishes it. That's it for that particular question. So as we take a look at the graph, you know, the more that we know about the graphs and able to do the graphs, then the quicker we can solve other entities, in this case, the inequalities. Okay, let's take a look at doing something similar, so another rational function, only now our directions are let's solve it algebraically. Another interesting piece about this particular inequality, notice we've got a numerator over a denominator less than or equal to, but now we have a number besides 0. Okay, so how do we handle that? We have to set this number equal to 0. Okay, so what does that mean then? We got to move this 3 to the other side of that inequality. So let's see, that's going to be 3x squared plus 13x plus 9 all over x plus 2 quantity squared minus 3 is less than or equal to 0. Okay. Now, when we've done these before, what we've had is we've only had this piece here. We did not have this extra constant out here. So that constant we really have to absorb back into the rest of this fraction and then go from there. So what we're going to have to do then is we're going to have to get common denominators. So this is -3 over 1. This other piece is over x plus 2 quantity squared. The common denominator, the quickest way to get those is just to multiply these denominators together. So 1 multiplied by x plus 2 quantity squared is simply x plus 2 quantity squared. So on the left side, I'm still going to have 3x squared plus 13x plus 9 over x plus 2 quantity squared minus 3, and now I need this to be over x plus 2 quantity squared also. Originally it was just 1, so since I multiplied the denominator by x plus 2 quantity squared, we also have to multiply the numerator by that same thing, and of course we're still less than or equal to 0. Now I need to expand this right side. So let's see, my denominator is still x plus 2 quantity squared, still less than or equal to 0. This piece on the left is still the same, 3x squared plus 13x plus 9. Now I'm going to subtract 3 times this thing expanded. So x plus 2 multiplied by x plus 2, just saving some space, writing it off on the side, would be, let's see, x times x is x squared, then plus a 2x, plus another 2x, and then plus 4. So this is going to be x squared plus 4x plus 4. And sometimes it's just a little bit easier to go ahead and take one of these pieces and just write it off to the side and say, hey, we know everything else is going to remain the same. Let's just simplify this one piece and then plug it all back in together. And so as we finish that up, let's see what we end up with. So our bottom is going to be still x plus 2 quantity squared. In the numerator, we still have our 3x squared plus 13x plus 9. Now we're going to distribute this minus 3 to each of these terms. So that's minus 3x squared, minus 12x, and then minus 12. Now we need to combine terms. Okay? So our denominator, we still have x plus 2 quantity squared. We still have less than or equal to 0. Let's see what we end up with overall on these other pieces. So at my 3x squared and a minus 3x squared cancel each other out. Let's see, I've got a 13x and a minus 12x, so that's just x. And then we have a plus 9 and a minus 12, so that's going to be minus 3. So we have x minus 3 over x plus 2 quantity squared less than or equal to 0. So that is much easier to look at and solve than what we had up here at the beginning as far as that whole expression. So that expression now is simplified into what we have down here at the bottom. Now we just have to solve this. This we could go ahead and just take a look at then as far as what are the key pieces of information. So if I was graphing it, when does the numerator equal to 0? And when is the denominator equal to 0? So that's when x is 3 and when x is negative 2. So now in this case, we were asked to solve it algebraically, so we're not going to go ahead and worry about the graphing piece. But we do want to go ahead and take a look at these are the critical areas. Okay, let's see, at negative 2, this is our denominator, so this would have been undefined. And this x equals 3, that was our x-intercept, so that would have been exactly 0 in that piece. So we do need to know those items. So overall, this would have been an asymptote if we were graphing, and this just would have been the intersection, the x-intercept specifically, so the intersection with the x-axis. Let's do a sign graph. Okay, so the sign graph. Okay, so let's take this piece here, and let's be on the left side of negative 2. Let's say negative 3. So at negative 3, what do we have? So negative 3 minus 3 is going to be a negative. And in this thing, whatever it is, we're going to square it, so it's going to end up being positive. So negative over positive ends up being negative. So between negative 2 and 3, let's choose 0. Okay, so that's between negative 2 and 3. So at 0, we've got negative over, and this thing's still going to be positive. So that, again, is going to be negative. Out here beyond 3, maybe let's choose 4. Okay, so when we do that, 4 minus 3 is a positive 1. And again, that's going to end up being positive. So overall, positive or positive is positive. So what we're interested in overall was when we were less than or, wrong item there. Let's see, when we were less than or equal to 0. So less than 0 here, less than 0 here, equal to 0 here. Okay, so as we piece that together, what is our solution? Our solution is negative infinity up to negative 2, union with negative infinity to 3. Okay, now notice the negative 2 was not included here on the right endpoint, and over here on the left endpoint was not included either, because that was when our denominator when it's 0, and that's when we're undefined. So we're undefined there, so we cannot use that. However, at 3, we were defined. That would have been the x-intercept overall. Okay, and so we could have graphed this overall if we would have graphed this a little more detail in there. Let me just go ahead and throw an x or a y-axis in here overall. And so with the y-axis in here, let's see, we would have been, if we would have did our horizontal asymptote, would have been over here, okay? Would have been our line y equals 0. And because we were x over x squared, so it would have been 1 over x. X is the end behavior. And overall then, since I got a negative 2 here, negative and negative on either side means I would have been looking something of this sort. And then I would have had to bend back down because my horizontal asymptote was 0. So that would have been a rough sketch of the graph, very rough sketch. Let me go back into Desmos here. I think I have this in Desmos. Yeah, I've got it over here. So this was the whole graph here. And so that's what the graph looks like. And on this one, let's see, if I go ahead and change this to x equals negative 2, that would have been an asymptote. And y equal to 0 would have been an asymptote. Okay. And so we have those in here. Let me go ahead and go back to the gear, change these, since these are the asymptotes, change these to the dotted lines. Okay. And so where are we less than 0? We're less than 0 from negative infinity to negative 2, and from negative 2 up to, and let's see if I just click on this graph, it shows me where the x-intercept is, and that is at 3. And then if I zoom in on this, okay, it's kind of difficult to zoom in, we can see that our function here in black is barely above our horizontal asymptote, but it is above it, and then it slowly starts to come back down a piece at a time. Okay, so if I click on that again, back over here, that would have been the high point. We're only 5/100ths above the asymptote, and then we come back down. Okay, but that would have been the graph. And what we were interested in, not to belabor the point, what we were interested in overall then on this question, whoops, was when was this less than or equal to 3? That was our overall item. Had we rewritten it, or we did rewrite it, we did the graph, and then we saw what it was overall. As far as this graph, let me squeeze back in here. Here we go. That would have been our graph overall. Okay. Now, that's doing it algebraically. The other way we could have done is if I was using just strictly a graphing technology. Let me go back into Desmos and show you what this would have looked like otherwise. So if I do this piece, and then get rid of these, and let me plug in here y equals 3. There we go. So if I get rid of that piece, because originally it was this function had to be less than or equal to this function. Okay. Let's see. Yeah, 3x squared plus 13x plus 9 over x squared plus, or x plus 2 quantity squared was going to be less than or equal to 3. So where does that happen? Okay, so it's in this whole region, okay, up to 3. Okay, so from negative infinity up to, now we do have this undefined piece at negative 2 still. Okay, so that would have had to have been taken out, but then we go up to 3, and that's what we had said as well. I believe, yeah, over here. Whoops, let me share that screen again. So over here, we said it was 3. So from negative infinity up to negative 2, and from negative 2 up to 3, and then beyond that, we were above this axis. What that looked like from the original equations, okay, was we were above the line y equals 3. When we had simplified it, then it moved it down to just looking at the x-axis here for the y equals 0. Okay, so kind of an interesting way to look at those and try to determine what's taking place, what's going on. But that's the end of this particular section. So in this section, we're solving rational inequalities and polynomial inequalities. We took a look at just graphing them. then also doing sign graphs, S-I-G-N. Okay? And so we did that by hand, and we also went out to Desmos and take a look at what the graphs look like just to verify that we had everything correct. Okay? Fascinating item. I always enjoy this particular section. Hopefully you did too. I don't think I made any mistakes, but if I did, please go ahead and let me know. That way I can fix those in the video. And then please take care of yourself, and I'll see you in another video.